In the previous lesson, we mentioned the widespread use of the plotting function and its related functions. In this lesson, we plan to expand on the use of this function to graphically represent data. The plot function is a two-dimensional, discrete plotter, meaning it takes two finite sets of points and plots the two data sets against one another. This can be seen if we look at the help file for plot. Type plot and hit F1. Notice that in the documentation they explicitly mention the 2D aspect. As you may have guessed, we require two data sets for this function, an independent dataset and a dependent dataset. First, we will define an independent dataset time with the following expression: t equals 0, 0.5, 10. Next, we will define a sample dependent variable to plot with the following expression: beta equals 0.1, alpha equals 2, and finally y equals beta divided by alpha dot times 1 minus exponent minus alpha times t. This is the simple expression for mRNA levels over time in a cell, given that beta is production rate and alpha is degradation rate. Note the use of the dot times operator as previously discussed. This is because t is a matrix and beta and alpha are both single values. Now that we have defined the independent and dependent variables, we plot them with plot t, y, where t is the independent variable and y is the dependent variable. A new window opens with this line called Figure 1. The line depicts y on the y-axis and t on the x-axis. This graph has two main problems. It is unlabeled and it captures much of the steady-state plateau at the end, resulting in less detail regarding the part of the curve that is changing, or in other words, the x-range is too large. We can change the x and y labels with x label, time in seconds, y label, mRNA levels in micromolar, and finally the title with title, protein, concentration versus time. Notice that the arguments for both of these are in single quotations. This is how MATLAB represents strings or textual pieces of data. All you need to know in this case is that for these three functions, MATLAB takes the strings you input and shows it on the active figure, which in this case is Figure 1. Suppose now that we want to look at this first, more interesting part of the graph. We can change the range in one of two ways, the first being axis 0, 5, 0, 0.05. Going back to the figure, notice now that the x-max value is 5. The axis function therefore takes it a matrix argument with the four values representing x-min, x-max, y-min, and y-max. This can all be seen in the documentation. The other way is to use indexing. To do this, we first close Figure 1 and type plot t 1 through 11 and y 1 through 11. Notice that since we used a resolution of 0.5, we stopped at 11, which was the index halfway through both t and y, which are of size 21. Now suppose we want to fix the lumpiness of the graph. To do so, we can simply change the resolution of t and subsequently y. Close Figure 1, and now type t equals 1, 0.1, 10, and y equals beta divided by alpha dot times 1 minus the exponent of minus alpha times t. And finally, plot t 1 through 51 and y 1 through 51. Notice that the line is much smoother because there are more points to represent this function. On a final note, suppose we have two functions that we want to compare. Let's define another function y2 as follows. Beta underscore 2 equals 0.3. And finally, y2 equals beta underscore 2 divided by alpha plus, open parentheses, beta divided by alpha minus beta 2 divided by alpha dot times the exponent of minus alpha times t. This equation represents the dynamics of the mRNA concentration when production rate begins at beta and is suddenly changed to beta 2. Let's replot these two together. First, close your figure 1 if it is open. Then type plot t, y, red, and t, y2, green. X label in time as before, Y label mRNA levels in micromolar, and title protein concentration versus time. Notice that we specified the color of the line after each pair of independent-dependent variables in the plot line. We can also add a legend with legend beta 1 and beta 2 to show that red is production rate 1 and green is production rate 2. Note that the order you give the labels should be the same order you gave the plot function. In conclusion, the plot function takes many inputs, the simplest being plot independent-dependent. X label, Y label, title, legend, and axis all can be used to change different aspects of this figure. Finer resolution data will give you more detailed plots, and finally multiple datasets can be plotted on the same figure using plot T1, Y1, T2, Y2, etc.